Okay, so now we're going to talk about voltage. Okay, so we discussed it the other day and decided that voltage was a measure of the amount of energy within an electron. Okay, now we can elaborate on this by saying it is the amount of energy supplied to a circuit or used by an electrical component within the circuit. Okay, so voltage is a measure of the amount, don't mind my dog, of energy supplied to a circuit via a power source or used by a component. Okay, so that's like if you wanted to measure how much energy got consumed over a resistor. Okay, so the way we measure our voltage is using a voltmeter. Okay, we measure it using a voltmeter. Okay, and the measurements are given in units of volts. Okay, which is a capital V. Now, voltage itself is also denoted by capital V. All right, so current is I, voltage is V. Now, if you were to increase the amount of electron energy in your circuit, you would be increasing the overall voltage of the circuit. Okay, so for example, in Australian generalized power supply, we usually have it supplied at around 240 volts. Now, what can happen, remember how we discussed short circuits yesterday, how all the energy must be consumed before re-entering the power source? Well, what we need to do to sometimes help with that is put in a transformer, and the transformer reduces the voltage, or in other words, acts as its own resistor, so that the voltage supplied to a component is at the level that it needs. So sometimes if you supply too much energy to a component, say your phone, you might overpower the phone and damage it, or if you supply too much energy to, say, a light bulb, you might burst the bulb, okay, and break it, and you'll end up cutting the circuit. So what you do is you put in a transformer before your circuit. So on your laptop chargers, you'll notice the big box on the edge of it near the power plug. Okay, that is actually a transformer, which helps to reduce the amount of energy going into your device. Okay, so similarly to voltage, we discussed previously what's known as potential difference. Now, potential difference is actually the measure of how much energy is being transformed or used over a given component. Okay, so your potential difference, which is voltage, okay, and you might remember I said potential difference is delta V because it's a change in V. That triangle means change in. Okay, change in V. Okay, potential difference is a measure of how much energy is consumed or transformed, sorry, not consumed, transformed over a given component or components. Okay, so that's your potential difference. Now, yesterday in our circuit with our sour worms, we looked at what resistors do. Okay, so now we're going to discuss what resistance is. Okay, so we've got resistance. Just grab that. Now we denote resistance with an R. Okay. Now resistance is the result of the atoms within your wire or component of a circuit restricting the movement of your electrons. Okay. And it measures how difficult it is for the electric current to travel through a component. Okay. So the resistance is a result of atoms in the wire restricting electron movement. Okay. And it measures the difficulty or how difficult it is for an electric current to flow through a component. Okay. Now, we measure resistance using a funny symbol or a funny unit called ohms. Okay, and that's after a person, so it's measured in ohms, which looks like it's actually a Greek letter. Okay, and that's what ohms looks like. Okay, so as with our sour worm activity yesterday, we noticed, or you could notice, that when you increase the resistance, okay, when you increase the resistance, you're going to increase the level of difficulty. Right. So that's what happens with resistance. Now, resistance can be dependent on a couple of things. First of all, different materials will have a different level of resistance. For example, your conductors, so your metals in particular, are really good, they allow really good flow of electrons, okay? So they would have a low resistance. Okay, so your metals would have a low resistance, and something that restricts electron flow, like rubber, would have a high resistance. Now, similar to our electromagnetic waves, there's a spectrum. So some are really, really good conductors, some are average conductors, some are average insulators, and some are really good insulators, okay? So there's a whole range of levels of conductors and insulators. Okay, so that's the first thing that resistance is dependent on, is the type of material. Okay, the second thing that is dependent on is the length of your wire or your circuit. So when you think about it, if you were to double the length of your wire in your circuit, okay, you are doubling the amount of obstacles or atoms that the electrons must pass through. So if you increase the length of your circuit, you will be increasing your resistance. Okay, so if you increase the length, you are increasing resistance. And the last thing would be your wire thickness. So when you think about thickness, I want you to think about a doorway and a lot of students trying to all get through that doorway at once. Now, if you were to have a very wide doorway, there would be a lot less resistance for those electrons or students getting through than there would be should there be a narrow doorway. So that's how resistance is dependent on wire thickness. For a very thick wire, the electrons can pass through easily, and for a very thin wire, it's much harder for a large quantity of electrons to pass through in the same amount of time. Okay, so the third variable is wire thickness. Okay, so it's dependent on the material, whether it's a conductor, an insulator, and how good it is. The length of the circuit or your wire, remember, an increase in length will increase the difficulty or resistance, and the wire thickness, which has an inverse effect. You increase the thickness, you decrease the resistance. Okay, now we discussed conductors and insulators the other day, so I'm not going to go over them, but if you could please write down your definitions for what they are and how they might affect your circuit, that would be greatly appreciated. Okay, so do that as a quick review, and then we'll move on to parallel and series circuits.